Software Center capstone team working on software regression testing on optimization in Jenkins. I am Harrison Malloy.
I am Callahan Stewart.
I'm Demetrius Fenton.
And I'm AJ Brown.
Wrong button. A overview of the things that we're going to talk about in this presentation. First, an introduction to ourselves, just covered, and the company, the solution that we have been working on, the schedule by which we worked on it over the course of this term, the progress that we've made over the semester and the current status of the solution, the various issues that we've encountered during development, summary of our postmortem, the future of this project, and a brief question and answer segment. Now, we have been working with Software Center in Sweden, a Swedish company that has the mission of strengthening the Swedish software industry by working directly with universities to make sure such that the research done in universities is relevant to the industry and that the industry has access to recent developments discovered in universities. They work directly with universities to accomplish this. We've specifically been working with Linköping University with Azim Ahmad, a PhD student from Linköping. Kristen Sandal, shown there, is the lead of our research team. We've had no direct communication with him. We've always been working entirely with Azim.
And then to outline the need or problem, large projects typically have large quantity of tests, and it's very inefficient to run all of them each merge. And many tests may be duplicate or very similar, where it becomes redundant to test all of them. And then you also must test builds before merging into production. So a solution to that is a program that determines test case similarity with standard input-output, provides the list of similar or different tests, and then it runs the tests in a Jenkins environment. And some of the benefits to this is it would allow for faster test time, which would allow for quicker updates. It can still do the full test at night. It would save server resources, allowing for a lighter test load, and it will be language agnostic because of the standard input-output, so it would be able to work on all setups.
So here you can see the completed tasks that we worked on in sprints 1 and 2. We'll go into more detail on these in just a moment. And here you can see the tasks that we worked on in sprints 3 and 4, and we'll also go into detail on those. So just for a brief status overview of the finished product, what we did is we gathered test cases from open source projects across the industry and converted their test cases into JSON format files, which we'll cover the template for that in just a moment. And what we did is we converted a previous iteration of this project from working on file-based input to standard input, so you can pass them in directly from a program as opposed to having to save them to a text file. We also converted text-based output to standard output so that this entire program can be run as a plugin inside of an integrated development environment, so you can select the test cases, run them, and get your output all from within the same program. We also restructured the entire program into a Jenkins plugin, so when you have your project set up in Jenkins properly, you can, on each build, identify which test cases are the most pertinent to the changes that you made, run them, and see the output all on each merge. So in sprint 1, we got acquainted with our project sponsor, Azim Ahmad, created a GitHub repository for our project, and then we took a survey of open source projects and gathered test cases from them, from a few different languages, Java, C#, and Python, to name a few. We also received the source code from the previous iteration of the product, which, as I mentioned before, was file input based and file output based, which couldn't really be used in a Jenkins plugin. But it did have the statistical algorithms we needed to implement for test case selection. We also researched the current implemented method of test case selection, such as the Jacquard index that was used. Just to familiarize ourselves with the similarity-based test case selection that we're going to have to implement. And then in Sprint 2, we've reformatted the source code to meet the Allman coding standard. This was because the previous project had been worked on by a few different people and really didn't meet any standard. So for the sake of ease of use for the future people that work on the project, we reformatted the entire thing. We also established a set JSON template that we were going to convert all of our test cases into. And this was extremely important because the template for the JSON file is going to really influence the effectiveness of the test case selection. So the more effectively we can specify the different aspects of a test case, the easier we can identify which test cases are similar to each other. Also in Sprint 2, we converted that file input into a standard input for ease of use in the Jenkins plugin.
Alright, so now to quickly cover the JSON template as described, the main components are we have the name of the test file name, as each individual test file will be one JSON file, and then the test cases is an array, each array having an object that contains the name of the test, the features, the specific requirements of the test, attribute tags. These would be things such as public, static, or what it could return, and then an array of each line of the test steps that would be involved for it. Next, in Sprint 3, we were able to finish converting it to standard output, and we were able to validate that the standard output was what we expected out of it. And then we began converting it to Maven for use in Jenkins. And for those of you that aren't familiar with it, Maven is a kind of a framework to allow ease in build management and help assist with project management. We then did a bit more research on how to properly set this up for Jenkins plugin, as there have been different ways of doing it over the years. And then we finally also set up the Jenkins environment within which the project would be. Right. And then for Sprint 4, we completed the conversion to Maven. We began work on the Jenkins plugin, and we also kind of did some finalized testing and some documentation to make sure that everything that was done up to this point was done properly. Then a short little demo video on how it works.
I need to click this.
Yeah.
Okay. Pause about 1 minute, right?
So the way it's supposed to work is for testing purposes, we had to manually enter one JSON test file per line, just so that way it could be read easily through the Java scanner. It takes a little bit of time to do this by hand. So it's got the name, test cases, name of it, the features that it would have. There's the second. And the third. And there's 5 total that were used for this one as kind of a shorter example on how it works. Fourth. And then the final one. And then end was sent alongside it to easily give a end of passing, make sure, or this is what you can do this, and then we can from here. As this was the old way of doing it, and then
I'll get us back on the.
there we go. And from here's the new form of the output. There's the 4 different range selections. These show the variety from 0 to 1 of similarity of the test case compared to other test cases in the NCD, the Jaccard index, the Sorensen dice, and the normalized Levenshtein. And then another sample bit from the output is showing, when you compare like 95% similarity in test features, it would display all the different ones that are given, and then it would do it for 10%, and so on down to 100%. And then some of the potential issues or risks that we came across during this project. There's the time difference between North Dakota and Sweden, which varied from 7 to 6 back to 7 hours, which meant that there could be potential long delays in response if we happened to send one as we were about to go to sleep for the night or vice versa. And it also meant that there's only a small window, typically between 8 to 10 a.m. in mornings that are on our mornings, which was at the end of his workday, that we could try and hold meetings. And then it came down to weather over the semester. There were some snowstorms that prevented us from getting to campus, and the potential flooding, which also prevented some of our morning meetings from happening, as we were not able to make it. Then some other issues that we had were when attempting to convert the project initially to Maven, there were conflicting bits of documentation on how to properly refactor for it, as the provided official documentation was very slimmed down, and any tutorials that were out there were for Maven 2, which is not compatible with Maven 3. And there was also the latest version of Maven that was used had one of the plugins that it shipped would break every time we tried to build with it. And it was unclear initially how to get the updated version for that. And then in addition, because we had to restructure our project directories in order for it to work as the new file type for Maven, when we used Eclipse to build it, it was no longer able to build at all because it did not see the proper file structure. And then some additional post-mortem summary. Things we've learned is that we need to better establish more reliable and consistent communication throughout projects. We also need to make sure that documentation is done as needed and not try and catch up with it a little bit later on. And then always a lot more time than you think you would need per each section. The next steps that will be done with this is there's a team at Software Center that this will be transferred to in order for them to pick this up, do any additional work that they would need to do and continue development for it. Then they will need to they'll probably have their own internal development system set up, so we would need to decommission the current one that we've been using to host the project. And that is it for the majority of our speech. Are there any questions from the crowd? Nice.
I guess I have one question. If the test case is changed, does it need to recalculate across the entire set, or is it able to only perform the calculations for the newly added test cases in some way?
As it stands, the current functionality would require going back up, or it has not been set up to change or fix only for changed test cases. It would need to do a full recompile, but because it would only need to compile them all once and would then be able to output the list of what is done, you would not need to rerun them until new test cases were added or test cases were changed.
Can you give a little more detail on the Jenkins plugin issues?
Some of the Jenkins plugins issues we were having is there weren't really there wasn't much documentation or tutorials on how to refactor a pre-existing application into a Jenkins plugin. There was only one kind of tutorial that I discovered for it, and it was designed and all the features in it have been deprecated. Because it used to be make a singular Jenkins class that would hook onto your jar or could hook with your existing one and work from there, but this would require finding very specific extension hooks to implement, inherit, and build off of, which requires a more substantial rework of the program than it was in its current state. Now, it was difficult trying to find the specific hooks for on-build complete, or even for when it hits build, than for running tests as well.
I guess, did you document all of this, or is there still only one
All-
very unhelpful tutorial on how to do all of this?
All of these issues I've been kind of trying to document in some form as I've been going through, more so in looking through the README whenever I would push to work on a separate system. I would just write, here's what I've hit, issues I've hit so far, which thankfully every issue, once it was solved, ran into a brand new error. But at least I kept a running track of these are things that would be I've had going wrong with this, so that way for future developing it can be noted that here's a way to try and fix some of these common problems.
Is Amon pretty much up to date on the details of your code?
We had
Yeah, he has access to the repo, doesn't he?
He at least has access to the repository. We hadn't spoken with him within like the last few days, but we will be meeting up with him on Thursday to discuss kind of the final state of things and where to go from here.
I had a question.
Yes.
This is an interesting project. I'm still trying to wrap my head around what's actually being compared between the tests. Could you give an example of what a test feature is?
The test or the ways that you can compare a test is one of the ways we can do it is by the test steps, and that basically compares the difference between each line of the test and compare, say if this one is just comparing if this stat number is equal to this or if this number is equal to this, those would be found as similar. And then with the test features, that could be things such as comparing if it successfully, or you could have it check if it is comparing if it throws this error or if it successfully posts to this API, or essentially you can compare, are these test steps similar, this percent similar, or are the things that we are trying to determine, or the parameters and such that we are using for the test similar enough?
So are the test steps, are they code or is it more of like an abstraction?
What we have done is, if I can go back to with the template, for the test steps, it is quite literally you take the test steps, or like each line of code from that step, you turn it into an individual string that is then put into an array inside of the template.
I see. Thanks.
Are there any additional questions?
I guess in the sample output you showed you had I think 3 or 4 different values where it calculates those. Are all of them necessary? It looks like you generally get a lot of agreement between them.
These, for this sample size, or since it was only a sample size of 5 test files that were put in for this particular one, there is a fair amount of similarities shown between them. However, it would be, or as the amount of test cases would grow and the file would grow, there'd be a bit more differences. This is mainly to show if you were trying to determine for your situation which of the 4 works best for you, that's how you would need these. However, for the average use case, they could be considered close or similar enough that they are not as needed in the end. And there is a way to configure the output to not send these out, but would only instead send the differences that could more cleanly be sent to testing.
And then you had mentioned that you used several different open source projects to test this and make sure it works with different languages. What was the largest test suite that you used?
That was so early in the project, it's hard to recall.
I think there was it had a few, the largest one I think had a few dozen test files, and each of them had a couple of different tests within. However, due to constraints, we had gone with the smaller one, which was only a handful of files, each of which had 2 or 3 tests within.
So maybe 100 or so, kind of upper bound.
That was the upper bound of what we had for
Yep.
testing at least, so.
So have you considered using something utterly massive just to see if it scales? Are there any concerns with that, or?
That is something that we could attempt to test in the coming days before our final meeting with our mentor, just to see what potential thresholds we could hit with the upper bounds. The only real upper bound I can think of would be, seeing as it is comparing amongst each individual test, there could be a issue if we run into the stack depth of the Java virtual machine, but that could be a different issue to cross once you hit 1,024 tests being ran, or you could try modifying that part of the JVM.
Thank you.
Thank you.